Assalamu alaikum. Welcome to my demo class for teaching assistant position. Today, I'm going to talk about the state of flow in open channel. First of all, I want to talk about the what is open channel flow. Open channel flow is a flow of water with free surface. State of flow is one of the important part in open channel. So there are two effect regarding state of flow. First one is effect of viscosity and another one is effect of gravity. Depending on the effect of viscosity, the flow type may be laminar or turbulent or transitional. The effect of viscosity is expressed by the Reynolds number. The mathematical expression of Reynolds number is Re is equal to Vr divided by mu, where V is equal to mean velocity, R is equal to hydraulic radius, and mu is equal to viscosity. The value of viscosity we considered 10 to the power minus 6 meter per seconds. And R is equal to hydraulic radius, R is equal to A by P. A means cross-sectional area of the channel and P is equal to weighted perimeter. So here the sum condition regarding effect of viscosity or Reynolds number. So what are the condition? If the Reynolds number is less than 500, then the flow type is laminar. And if the Reynolds number is in between 500 to 12,500, then the flow type is transitional. And if the Reynolds number is greater than 12,500, then the flow type is turbulent. Now, another effect is effect of gravity. When the flow is dominated by the gravity, then the flow type can be identified a dimensionless number. So this number is also known as Froude number. The mathematical expression of Froude number is Fr is equal to V divided by root over GD, where V is equal to mean velocity and G is equal to, as already we know that acceleration due to gravity, we consider G is equal to 9.81 and D is equal to hydraulic depth. And hydraulic depth is equal to A by T, where A is equal to the cross-sectional area and T is equal to top width of the channel. Here, there's some condition regarding Froude number. So what are the condition regarding Froude number? If the Froude number is less than 1, then the flow type is subcritical flow. If the Froude number is equal to 1, then the flow is critical flow. And if the flow type is supercritical, then the Froude number is greater than 1. So here the some theoretical discussion regarding Froude number and Reynolds number. We will discuss it after solving the mathematical problem. Now I switch to the mathematical problem regarding state of flow. Now I'm going to solve a mathematical problem regarding state of flow. So what is the problem? I highlight the problem. So the problem is a trapezoidal channel has a bottom width of 6 meter and side slope is 2:1. Compute the discharge and determine the state of flow in this channel if the depth of flow is 1.5 meter and the mean velocity of flow is 2.3 meter per second. So now I'm going to solve this problem. So first of all, I want to note what are the given data. The given data are, first of all, the channel bottom. Given the channel bottom, B is equal to 6 meter, side slope given 2:1, so S is equal to 2, and depth of flow is 1.5 meter, and mean velocity is 2.3 meter per second. Here the figure of the channel, cross-sectional figure of the channel. So now I'm going to solve the mathematical problem. For trapezoidal channel, we already know the area is equal to B plus SH into H. So all data are given. B is equal to 6 meter, S is equal to h is equal to 1.5 meter. So we substitute the value and we got a is equal to 13.5 meter square. And for trapezoidal channel, weighted perimeter formula is P is equal to B plus 2H square root of 1 plus S square. All value are given and we substitute the value and we got perimeter, weighted perimeter of the channel is 12.71 meter. And now top width. For trapezoidal channel, formula of top width P is equal to B plus 2SH. So we substitute the value and we got the top width V is equal to 12 meter. And now hydraulic radius. Hydraulic radius formula R is equal to A by P. So we substitute the value and then we got hydraulic radius R is equal to 1.06 meter. And now hydraulic depth. We already know hydraulic depth D is equal to A by B. So we know the value of A and the value of B. We calculate the all this value. So we substitute the value and we got hydraulic depth D is equal to 1.13 meter. Now, first of all, we need to calculate the discharge. So the formula for calculating discharge, Q is equal to A into U. So we know A is equal to 13.5 meter square that we calculated before, and given mean velocity U is equal to 2.30 meter per second. So we substitute the value and we got discharge Q is equal to 31.05 meter cube per second. And now we are going to calculate the effect of viscosity. We already know the formula for effect of viscosity R is equal to UR divided by mu. So value of U given 2.3 and hydraulic radius we calculated the hydraulic radius R is equal to 1.03 meter, and we know we consider mu is equal to 10 to the power minus 6. So we substitute the value and after calculating the value we got Reynolds number R is equal to 2.438 into 10 to the power 6. So that is this value of Reynolds number is greater than 12,500. So now we can say that the value, the flow type is turbulent, because we already know if the Reynolds number value, if the Reynolds number RE is greater than 12,500, the flow type is turbulent. So in our mathematical problem, the Reynolds number is greater than 12,500. So we can say that our flow type is turbulent flow. So now, I'm going to calculate the effect of gravity. So we already know the formula regarding effect of gravity is U divided by root over GD. So U is equal to given 2.3 and we already know G is equal to 9.81 and D is equal to hydraulic depth. We calculated that we got the D is equal to 1.13 meter, and then finally after calculating all this value we got Froude number is 0.69, and that is Froude number is equal to less than 1. So we already know that if the Froude number is less than 1, then the flow is subcritical flow. So now finally we can say that our flow type is subcritical turbulent. Why subcritical turbulent? So now we are in this slide. Now here we see that in our mathematical problem we meet this condition. Our Froude number is less than 1 and Reynolds number is greater than 12,500. So in our mathematical problem we meet this condition, and then we can say that our flow type is subcritical turbulent flow. So that is the a problem regarding state of flow. So thank you for watching my demo class. Assalamu alaikum.